Light 6. Dispersion and scatter. In this video, I will be discussing the concepts of dispersion and scattering of light. At first, we can see the refraction of light through a prism. What makes prism so special? Okay. In the case of refraction, the incident ray is refracted by an angle d. Here PQ is the incident ray and the overall refracted ray RS is refracted by an angle d as shown in this figure. A prism is formed of glass. It consists of two triangular bases and three rectangular faces. The angle between two rectangular faces is called the angle of the prism. In this figure, A is an angle of the prism. Now, we can see PQ is a ray incident at the face AB. At E. At the point E, the ray undergoes refraction. Since the ray comes from a rarer medium into a denser medium, it refracts towards the normal. Then, at point F on side AC, it undergoes refraction. But in this case, the ray goes from a denser medium to a rarer medium. Hence, the refracted ray goes away from the normal. Here, RS is the refracted ray. So, thus we can see that a incident ray will be refracted by an angle D in the case of a prism. In the case of a glass slab, there was no change in angle, only the incident ray was shifted laterally. This is something that makes prism special, and this is the main reason why dispersion happens in prism. Now we can see the concept of dispersion. The dispersion of light is the phenomenon of splitting of a beam of white light into its 7 constituent colors when passed through a transparent medium. A rainbow is caused due to the dispersion of sunlight by the raindrops. In case of a rainbow, the raindrops act like small prisms, and the refraction of light, as we have already discussed in the case of prism, happens inside the raindrops, which causes dispersion of the sunlight. Now light passing through a glass prism is dispersed. What is the cause of dispersion? Basically, the cause of dispersion can be explained as follows. The refractive index of many materials, such as glass, varies with the wavelength of color of the light used. This causes light of different colors to be refracted differently and to leave the prism at different angles, creating an effect similar to a rainbow. Dispersion through a glass prism. This figure shows the dispersion of white light when passing through a glass prism. The white light is split into its constituent 7 colors, which is given by Webb-Geor, that is violet, indigo, blue, green, yellow, orange and red. In this case, red is deviated the least while violet undergoes the most deviation. Red is having a higher wavelength than violet. Now, atmospheric refraction. Our atmosphere also consists of many materials having different refractive index. Hence, refraction also happens in the case of atmosphere. That is, the light coming from stars get refracted when it passes through our atmosphere. And also, the constituents of atmosphere keeps on varying, and this causes the twinkling of stars. Now, advanced sunrise and delayed sunset. This is also caused by refraction. Hence, the apparent position of the sun appears to be shifted. In the case of advanced sunrise, the sun is visible 2 minutes before the actual sunrise. The actual sunrise is the time when the sun actually comes to the horizon. Similarly, in the case of sunset also, it stays 2 minutes after the actual sunset has occurred. Now we can see the concept of scattering of light. The basic process in scattering is absorption of light by the molecules of medium, the propagating medium, followed by re-radiation in different directions. That is, the strength of scattering depends on the size of the particle causing the scattering and the wavelength of light. According to Rayleigh, the scattering is inversely proportional to the wavelength of light, fourth power of wavelength of light. Hence, the violet light is scattered most and red light is scattered least. Hence, red is used in boards to show dangers. When we look at the sky, we see it blue because blue is scattered the most. Now, another consequence of scattering of light by the atmosphere is the red appearance of the sun at sunset and sunrise. At these times, the sunlight has to travel a large distance through the atmosphere. The blue and the neighboring colors are scattered away and only the red light reaches our eyes. That is why only the red light is visible. Now, Tyndall effect. Tyndall effect is a visible scattering effect of light on particles along the path of a beam of light passing through a colloid system. This effect can be used to detect colloid systems. Some examples of Tyndall effect. First one, the visible beam of headlights in fog is caused by the Tyndall effect. The water droplets scatter the light, making the headlight beams visible. Another one is the same effect occurs when flour is mixed with water in a glass. When the light is shined on this glass, it appears blue, since blue is the of the shortest light wave and it is only able to pass through the dense mixture. Hence, this is the end of this video. In this video, I have discussed dispersion and scattering. If you have got any doubts in any of the concepts mentioned in this video, please comment in the section below this video. Thank you.